Hi guys, so we have this question on calculus which says evaluate the following limits. So we have these questions. Let's see how we can break them down. So to start with, we have the limit as x approaches 4 over this particular function. So what we're going to do is this. We're going to first need to factorize the numerator. So the reason why we cannot go direct and replace 4 with x with 4 is because we're going to get a 0, which will make this undefined. So let's factorize this first. Our product in this case is 12 and our sum is -1. So two numbers, we multiply them, -12, we add them, we get -1. That will be -4 and 3. So this can become x squared minus 4x plus 3x minus 12. Then we can factorize here, we get x minus 4. Same thing, we factorize here, we'll get x minus 4. So this gives us x plus 3, x minus 4. So having factorized that, now we can go ahead and just replace so that we get the limit as x approaches 4. Factorizing the numerator, we got x plus 3 and x minus 4. The denominator is x minus 4. So we can clearly see that this cancels with this, leaving us with the limit as x approaches 4 of the function x plus 3. Then now we can go ahead and just apply the limit. So this implies that where there's x, we replace with a 4 and we add that to the 3, and hence our answer is just 7. So we can represent our answer as limit as x approaches 4 of the function, this one, over x minus 4, it will approach 7. So that's our answer for the first one. Okay, let's go to the second one. Okay, so our second question, this one that we have here, let's see how we can express it. So what we're going to do is this, first of all. Let's first add these two fractions. So let's just do it here, it's fine. We can say the limit as x approaches 2. So first of all, let's break this down so that we have it as, since two squares are subtracting, that's a difference of two squares. That is x minus 2 and x plus 2. That. So limit as x approaches 2. So in this case, our LCM is what we have here. So the LCM is x minus 2 and x plus 2. So if this goes into this, we'll get this part times 1, we'll have x plus 2. Minus, if this goes into this is 1, 1 times 4, we just have 4, like that. So this can reduce to limit as x approaches 2. So in the numerator there, we just remain with x minus 2 divided by x minus 2 times x plus 2. So again, just like we did in the previous question, this can cancel with this, leaving us with the limit as x approaches 2 of the function 1 over x plus 2. So we can go ahead and just replace x with 2, so that we get 1 over 2 plus 2. Hence, this gives us 1 over 4. So the limit as x approaches 2 of the function 1 over x minus 2 minus 4 over x squared minus 4 is equals to 1 over 4. Okay, so we're done with that. Let's go to the next one. Okay, so this is our third question. So for this one, what we're going to do is, let's first add the two fractions in the numerator. That is the limit as u approaches 0. So for the numerator, we know that the LCM is u minus 1 and u plus 1. So if this denominator goes into this denominator, we get u plus 1. U plus 1 times 1 is u plus 1. This goes into this, we get u minus 1. So u minus 1. But remember, there's this u. So we can just say all this is divided by u. Hence, the limit as u approaches 0. So this one and this one can cancel out, leaving us with 2u divided by u minus 1 and u plus 1, which is just a difference of two squares. Then we multiply this with 1 over u, the reciprocal of this. From there now, we can see that this u and this u can just cancel out. So at this stage, we can just say, first of all, we have this 2 in the numerator divided by u minus 1 and u plus 1. So let's apply the limit by replacing u with a 0. So we'll get 2 divided by, that's 0 minus 1, we'll just get negative 1. 0 plus 1, we'll just get a 1. So this just gives us negative 2. Hence, the limit as u approaches 0 of the function 1 over u minus 1 plus 1 over u plus 1 over u, all this is just equals to negative 2. Okay, let's go to the next one. Okay, so now question D. So for question D, we have root t minus 3, t minus 9. So if we try to replace 9, we replace t with 9, we'll get 3 minus 3, which is a 0. Same thing here, 9 minus 9, which is a 0. So what we can do in this case is we need to factorize the denominator. So I want to use the concept of difference of two squares. In this case, we have t, which can be written as this. That 9 can be written as 3 squared. So since the square root cancels with the square, we still remain with this t that we have here. So this becomes limit as t approaches 9. So numerator is okay as it is, but the denominator becomes the root of t squared minus 3 squared. So now we can see that we have a difference of two squares. Remember that if you have a squared minus b squared, the difference of two squares is a plus b and a minus b. So that's the concept to apply. So in this case, this will imply that the limit as t approaches 9, so numerator is root t minus 3. Denominator, the difference of two squares, will have root t minus 3 in brackets and root t plus 3, like that. Then at this stage, we can clearly see that this cancels with this, leaving us with the limit as t approaches 9. So in the numerator, we just remain with 1 over the root of t plus 3. At this stage, our job is just to replace t with 9. Hence, we'll get 1 over the root of 9 plus 3. This gives us 1 over 3 plus 3. Hence, our answer is 1 over 6. So, let's just write the expression as the limit as t approaches 9 of the function root t minus 3 over t minus 9 is equals to 1 over 6. So just like that, we have the expression we're looking for. So let's go to the next question, which is part E. So for part E, which is the limit as x approaches 1, so let's go through it. Okay, so let's do question E now. So for this question E, this is what we'll do. Let's rewrite it this way. X to the power negative 1 is as good as 1 over x, like this, minus 1. Now all this is divided by x minus 1. So let's just consider the numerator first. That is the limit as x approaches 1. So the numerator, which is 1 over 1 here, the LCM for this particular numerator only is x. So x goes into x once, times 1, that is 1, minus 1 into x is x, times 1, that is x. Now remember, there's this denominator, which we can write as this, like that. So this becomes limit as x approaches 1. We have 1 minus x divided by x multiplied by the reciprocal, which is 1 over x minus 1. So at this stage, you can see that here we have 1 minus x, here we have x minus 1. These two cannot cancel out. So what we'll do instead is this. We'll say the limit as x approaches 1, 1 minus x over x. So for this part, let's factor out a negative. Factoring out a negative here, like this, will leave us with, so if you factor out a negative, the 1 is a negative, it will become a positive, the x is a positive, it will become a negative. So this is as good as saying 1 becomes positive, x becomes negative. So that if we push the 1 into the bracket, we get back to what we had here. So once we do that, we can now see that this cancels with this, leaving us with a negative 1 here. Hence, the limit as x approaches 1. So in the numerator there, we just have a 1. In the denominator, we have a negative 1 from this negative times this x, so that is negative x. We replace the x with a 1, we just get 1 over like this, then this is just as good as negative 1. So the limit as x approaches 1 of the function, this one, over x minus 1 is simply equals to negative 1. Okay, so let's go to the last question now. Okay, so this is our last question, question F. So for this one, we cannot factorize. So instead, we can just go ahead and replace x with a 0. So we get this divided by 0 sine 0. Cos 0 is 1, so that is 1 over 1. Sorry, that's 1 minus 1 is 0, giving us 0 over 0. So 0 over 0 is indeterminate, meaning that we have to use L'Hopital's rule. So we can say applying L'Hopital's rule. So according to L'Hopital's rule, we have to take the derivative of the numerator as well as the derivative of the denominator. So this function will become the limit as x approaches 0. The derivative of this numerator is simply 0 minus, remember, constant derivative 0. The derivative of cos is a negative sign. For the denominator, we have x multiplying with sine. So we have to apply the product rule. Our first function is u, which is x. Our second function is v, which is sine. The derivative here is 1. The derivative here is cos. Product rule is uv prime plus v u prime. So we do the replacing. Our u is x. Our v prime is a cos. Our v is sine, and our u prime is 1. So replacing the product rule here on the denominator, what we get is x cos x plus the sine of x. So this reduces to limit as x approaches 0. So in the numerator, we just have sine x divided by x cos x plus sine x. So we now try to replace x with 0. Let's see what we get. So in the numerator, if we replace this x with 0, we have sine 0 divided by, replace this x with 0, this will be 0 plus sine 0. Now, sine 0 is 0. So this is also 0 over 0. So since we still have 0 over 0, this means that this is still indeterminate, meaning that we have to apply L'Hopital's rule again. So, reapplying L'Hopital's rule. So, applying this rule means that we need to take, for this function here, we need to take the derivative of both the numerator and the denominator. Hence, let's see how it goes. We have the limit as x approaches 0. So the derivative of sine is a cos divided by the derivative of this part here that we have here. These two functions are multiplying. So we have to apply the product rule. That is for x, that is our u. For cos, that is our v. So u prime is 1, v prime is negative sine. So product rule, u v prime plus v u prime. Let's replace. Where there's u, we put x. V prime is a sine. Is this correct? Yes. Then where there's v, that's a cos. Then where there's u prime, it's just a 1. So this is the derivative for this particular function here. So let's replace with the derivative, of which we can just rewrite it as cos x minus, there's a negative coming from the sine, minus x sine x. Now, this is the derivative for this part. We still have this sign here, of which the derivative of that sign is cos x. So, the limit as x approaches 0. So, numerator, we just have a cos. So, cos plus cos will get 2 cos x minus x sine x. So let's try to apply the limit now. If we still get 0 over 0, we still have to apply log to 0. But in this case, this will imply that in the numerator, we'll have cos of 0, 2 cos 0, minus 0 times sine 0. This will give us cos 0 is 1. This here, cos 0 is 1 times 2, so that's just a 2 minus 0, giving us half. Hence, we can conclude by saying the limit, the original question, as x approaches 0 of the function 1 minus cos x over x sine x is equals to half. So there we have it. That's how we solve these questions under limits. Thank you very much.